My Tourette's. Sorry.
So, bad thing is, I don't know what happened to the projector, so we're gonna move. I tried turning it around for small groups today and then it didn't do anything for us, so. This first theorem we want to talk about is SAS inequality theorem. So we talked about SAS before, and SAS means, obviously, side angle side. So we're going to look at a combination of what they give us and try to figure out if we have information that includes side angle side. This theorem is also called the hinge theorem. So if you hear hinge, this is what they're referencing in the book. Okay? The first two theorems that we talk about today, they are obviously in your book. They're on page 371. So if you're a words person, this is why we didn't write it down in the other class, because if you look at it up here, it's a really, really big one. So again, it's in the book. If you're a words person, you can just turn to 371 and write the words. Okay? Here's why the other reason we don't put the words down. Because just listen to what it says. It says, if two sides of one triangle are congruent to two sides of another triangle, and the included angle in one triangle has a greater measure than the included angle in the other, then the third side of the first triangle is longer than the third side of the second triangle. Piece of cake, right?
Yeah. I didn't listen to a single word.
So, instead of trying to do that, we're going to make a triangle. So draw a triangle. Let's call this one ABC. And then let's try to make the first and this one, and then we'll make something like this. And then we have DEF. So obviously it doesn't have to look exactly like mine. But what this is saying now is this. If two sides of one triangle are congruent to two sides of the other, can I do that? Yeah, I can do that. I'm going to say AB is congruent to DE. And I'm going to put little slashes in, right? And then I'm going to say AC is congruent to DE, or DF, sorry. And then realistically, could we all assume that this right here is way different than that side right over there by just looking at it? Now, I know we said that we shouldn't look at it, but what this is saying now is we're looking for side angle side. So what angle would we have in order to have side angle side from what we are given right there? Angle D and angle F, right? So we're going to compare these. So if they're congruent, then the two triangles are congruent by side angle side. But basically, we're talking about inequalities today, so we're going to say that this angle right here is 60 degrees, and this angle right here is 75 degrees. Okay, so again, now let's read the words. If two sides of one triangle are congruent to two sides of another triangle, and the included angle, remember what that means? The included angle is the angle in between. So if the included angle is greater than the included angle of the other, the corresponding sides or the sides opposite of them should have the same characteristics. So if this is 60 degrees, we're going to use that to talk about that side over there. And if this is 75, we're going to use it to talk about that side over there. So if this angle is bigger or smaller than this angle, what would we think about the sides? The same thing. Say it louder. Say it louder. What you said, say it louder. EF then has to be greater than BC. Right? Because the side opposite of it should also be bigger than the side because the angles are bigger.
So we don't have to have the little line over top of the segment?
In this, technically, you wouldn't have to because we're talking about lengths. If you put them there, we're not going to, be anal about that. Okay? But does everybody see why? So because this angle is bigger than this one, the side opposite has to be longer than that side. Okay? So then theorem 514 is the converse, which means what? the opposite, right? So in this one, we had two sides and the angles. Now we're going to talk about the third side. So again, if you're a word person, you can go through here and do the same thing. Copy this down. If two sides of one triangle are congruent to two sides of another triangle, and the third side in the first triangle is longer than the third side of the second, then the angle opposite of that should be bigger than the other one. So, same difference, but now we're just going to talk about the sides. So you can basically draw the exact same triangles. And again, if we call this A, B, C again, with the next one looking like this, and we call it D, E, F again, we say that this is congruent to this still, this side is congruent to that side still, and then instead of giving you the angles, they're going to say this side is 12, and this side right here is 17. So now we're going backwards because we're using that third side, and we're going to talk about that angle right over there, and that angle right over there. So we would say in this case, what? Angle D is greater than angle A. And Aiden said it with 3 letters. That doesn't matter in this case, but he can always use 3 letters. But he doesn't necessarily have to because they're separated. So we could get away with saying D is greater than A. But everybody see why? Because this number is bigger than that. Now the ones that get a little confusing are when our shapes are something like this. All right? So when we have this shape, everybody still see that we have 2 triangles? But if we would say that this side was congruent to that side, would we have another side that's congruent even if there's no slashes given? The other side would be this side that's reflexive, right? So we could say that those are congruent. What you have to then zone in on is what angles would we be talking about? Again, it's always the included angle so we can make side angle side. So realistically, we're comparing this angle right here to that angle right there, to use that particular theorem. Okay? Questions with the theorems? So here's the really hard part, is because you can't put the example up on the board. So you might have to move around a little bit to see the example today. So here's my first picture. And we're talking about, they say compare the measures of AD and BD. Okay, so if I look at this right here, again, I notice right here, I have side, angle, side, because DC would be congruent to itself by the reflective property. And so then I come back and I look at my angles, they're not congruent, so I can talk about the sides. So I'm looking at the sides opposite, and what would have to be bigger than the other? AD has to be bigger than DB because 70 is bigger than 68. Make sense? Okay? And then the other example would look like this. And again, this one's even harder to see because the numbers are smaller. But again, so this was the figure that I kind of tried to draw right over there. All right? So if you can look at this one, you see the little slashes. My KM would be congruent to itself. And so then I'm talking about this angle down here and, this angle right here and this angle up here. And so because 7.2 is bigger than 6.1, this angle down here. And so now, like Aiden did in the first one, we have to use 3 letters because there's 2 M's and there's 2 K's. So in this particular case, we would say KML is bigger than JKM because of the lengths of the sides. That makes sense? And again, I apologize that it's hard to see. So, as we said, here's my answer. Okay? Questions there? Now, to me, that part's not real difficult. The next part, a little bit more. And the next part talks about the range again. So we're going to try to do this now, but now we're going to try to do it with the range. What does it mean by the range? We're trying to find lengths of something that would include all of the possible answers. So when they ask you to find the range, you're going to write two inequalities for every single problem. The first inequality, you're going to write from the theorems. So you're going to look at the figure, and you're basically going to set up some kind of inequality by looking at the information that was in the theorem, or in the example. So, the most important part of this is that you always want to write the variable part first. So, realistically, I could say x is less than something, or I could say x is greater than something. And then we'd fill in that blank. So every single time, because obviously I could write the x part after it, but it's just going to be way easier if you write the variable part first. What you also have to realize is that in some of the problems, instead of just having an x, you're going to have a quantity. So you could say 3x plus 4 is less than something, and 3x plus 4 is greater than something. So you could have to use the entire quantity that's given to you in the problem. Okay? That's going to be my first inequality every single time. And again, they come from the theorems. The second inequality, I'm going to base the second inequality off of what I wrote as my first inequality. So if the first one, the original inequality that we just made in number 1, is x is less than, if I think about all of the angles in a triangle, what do they have to all be less than? 180. But what do they all have to be greater than? What's the measurement of an angle in a triangle have to be greater than? 0. 0. Okay? So, if my original says x is less than something, my second inequality is going to be it's got to be opposite of this, so it's going to be greater than, and as Aiden just said, greater than 0. So if the first one is less than, the second one is automatically x is greater than 0. This x again could be this quantity, so whatever your quantity is would just fit in here. And you would use that whole quantity as the x part in both inequalities. So realistically, this one could have said 3x plus 4 is less than 17, and then 3x plus 4 is greater than 0. It's always going to be greater than 0, though, because of positive angles in triangles. Make sense? If the original inequality is x is greater than whatever we're doing, my second one has to be what? What do you think? Less than what? 180. Awesome. So again, I'm going to write the first one from the theorem. If the first one says x is greater than, I have to always write x is less than 180. And again, that x is just saying the variable part. So again, if we had this as our quantity, we would put that whole quantity into that inequality. We would solve both of them and then write a compound inequality for our answer. Okay? So, I know those words are kind of confusing, so let's try to, again, look at it. All right. Those of you that can't see it, I'm going to try to draw this one real quick. I got enough problems in my life. M? This was 18.
141 is the you erase that line. It's really bothering me. Then 9 and this was 2 is the other angle.
People.
And 16 is 9.
All right. So, Where's my figure?
All these can
Everybody see that one better? Sorry, I forgot to tape it in the first class. That's why you guys are getting stuck with this today. So, think about what we just got done talking about. I'm going to look at my information and I'm going to write an inequality because of one of the theorems. So, I'm going to zone in here. Do I have side angle side?
LD is supposed to be congruent to DN. That's what the picture shows.
Oh, I don't have this one, right? Thank you, John. So I forgot my little slashes. Now do I have side angle side? Yes, because what is congruent to itself?
MD.
MD. So realistically, we could have came back and put these two little slashes there. So here are my angles that I'm given, but basically we have to use that information from the sides opposite of them. So again, I'm going to always start out with the part that has the variable. So 9a plus 15 is what compared to 141? Why? Perfect. Everybody agree? Everybody, don't just say sure. Know why that is. Because 18 is bigger than 16, right? So, and what's my second one? So, again, I always use 9a plus 15 first. X is greater than 0. Exactly right. But instead of using x, now we're going to put that quantity in there. Okay? Solve both of them. Say it one more time. If the first one is less than, the second one has to be greater than, always. And so, but it always has to be greater than 0. Because if you think about the angles inside of a triangle, it has to be at a positive angle. So it has to be bigger than 0. Alright? Then we just go through and solve. How would I solve this first inequality? Subtract 15 from both sides. And divide by 9. So A is less than, I think, 14, right? Yeah. If I solve this one over here, 9a is greater than negative 15, so a is greater than what? Negative 5/3, right? Now here's the question. Can I have a negative answer as part of my inequality?
Because no angles negative.
So this is the confusing one, because remember when we did this with the range the other day, when we had a negative one, we just threw it out? But basically, we're not saying that the angle is a negative answer. We're saying A is a negative answer. So when we put that negative back into that quantity, though, sometimes, if we then go through the process of figuring out what that quantity is, you could still get an answer. So today, you cannot throw out a negative answer. You're going to use it. So now just write the rest of it. A is less than 14, and it's greater than negative 5/3, and I'm going to include that negative 5/3 today. It has to be bigger than that. So realistically, what's a number that's bigger than negative 5/3 but is still negative? Negative 1, right? If I put negative 1 into this quantity right here, what would I get? Negative 9 plus 15 would be what? Positive 6. So you see how I still get a positive angle even though my A was negative? So we're not actually answering that the angle is negative. We're answering that A is negative. And in this case, it would still work. Does that make sense? Okay.
Does that mean you can't find the exact number of that angle?
Well, I could. Well, yeah, you'll never probably know what exactly is. We're just saying that
Between those two.
in between there, any of those numbers that I picked would make that actually true. So yeah, to zero in on it, anytime that I picked one of those numbers, then realistically I'm zeroing in on that particular one. But there's a lot of answers that could fit. Okay? So, let's try another one. Can everybody get this? Can I erase it? Too late. It's erased. Yeah. the carvers. Try to draw it too much. So if you can see this one, you can, I want you to try to do this one by yourself. I'll draw it up here again real quick, but if you can see it, try to figure out what you would write for your two inequalities. Because this one's even harder to see. 9, 11. And this one was
7 plus 5. And
I'm
then
gonna get busy.
Y is on the bottom.
Z is on the left, or wait, no.
Yeah. Or Z is on the left, X is on the right. Top one's W.
Alright. And then they tell me, they gave me numbers, right? So, first off, can you see that we have side equal side? So instead of the slashes, they give us what? The 8s, right? So obviously, even though that they don't give us the slashes because the numbers are the same, those are congruent, and then we can say that that's congruent to itself again. So try to write down the inequalities from this particular one. And then try to figure out what your second one has to be. Everybody think you got it?
No, I can't even think, I don't even know where to start.
So 7n plus 5 and 47. Between this angle and this angle, if I look at diagonal and look at those sides, which of the angles has to be bigger? 7n plus 5, right? Because the length of the side opposite is bigger than that length. So this angle right here has to be greater than the other. Okay? And, so now I gotta have another one. And I'm always gonna use 7n plus 5. But because the first one was greater than, the second one has to be less than and less than 180. Because again, every single angle in a triangle has to be less than 180 degrees.
So how was that one 0?
Because the original one was less than. So then the other one has to be greater than, and it has to be greater than 0. My angles in a triangle always have to be bigger than 0, but less than 180. Right? You don't get what?
So, because that one is the 180,
Because the original problem, this one right here, said that this was less than 141. If it's less than, the other inequality has to be greater than. One has to be less than, one has to be greater than. It's got to be opposite, right? So because this one said less than, this one has to be greater than, and all my angles have to be greater than 0. Every single time. Think about a triangle. Can I ever have a negative angle in a triangle? It's impossible, right? So that's why I say it's greater than 0. This one, my first one by the theorem, because 11 is bigger than 9, 11 has, or this angle opposite of 11, which was 7n plus 5, has to be bigger than this angle that was opposite of 9. You understand that part? That's from the theorem. The two theorems that we talked about. This side is bigger than this side, so this angle has to be bigger than that angle. And that's what I just write down. This angle, which was 7n plus 5, has to be greater than this angle, which was 47. Because it's greater than, the other one has to be opposite, like Ralph said. So if the first one's greater than, the second one has to be less than. And then it's always less than 180. It's always greater than 0, but it's always less than 180. Because again, I can't have an angle in my triangle that's bigger than 180. Can never happen. And so that's why I write those two. Okay? Did you do the math? N is what?
Less than 6, but greater than 25. Or, I don't know, other way around.
25 and and 6?
Whatever.
I know.
Let's look it up.
I know. I know.
What am I doing?
Yeah. I know. Now, here's the thing. Just think about this one. Okay? I want you to just think about this. If we did the other theorem, where we're talking about the lengths of sides, what has to be true about a length of a side? It just has to be greater than what? The length of any side of a triangle. The length of this side right here, or this side, has to be greater than what? 0. Because can I ever have a negative length of a side? No. Now, does it matter how big it is? Realistically, it doesn't, right? I can make my triangle as big as I wanted to. So if you would do this in the assignment, and you're talking about the lengths of the sides, you just have to say that it's greater than something. You don't have to say that it's less than. Because a side doesn't matter how big it is. I can, well, realistically, we'd run out of room, but I could draw it as big as I want. Okay? Questions?